Hi, my name is Robert Hosking, and this presentation is about data in the distributed web. So, data in the centralized web adheres to the client-server model. The data lives on a server, and clients make requests for that data, and the server gives it to them. A URL is simply a request for some data. If we dissect this simple URL, we see the protocol definition, HTTPS, followed by a domain name, which resolves to an IP address of some server, followed by a file path, which describes the location of the file on the server. If that file gets moved to another folder, this URL won't work. We'll get a 404 error. If the file moves to another server, the link is also broken. The internet was built around location, and this is bad for privacy, and it doesn't reflect the transient nature of data. This sucks because we don't intuitively think of the internet in this way. The internet feels like this omnipresent thing that we just access from anywhere. That's why we call it the cloud, but the cloud is just someone else's computer. These pictures are of one of Facebook's data centers. I used to drive past this one on my way to school every day. It's a huge warehouse packed with thousands of servers and probably millions of hard drives. It has a full-time 24-hour security staff and a few dozen employees that maintain the servers. This is a multi-million-dollar piece of internet infrastructure, and it's been paid for with advertising revenue, as Facebook is primarily an advertising company. Every major internet company has data centers like this one, or they rent space in a shared data center somewhere. These companies are increasingly pressured to make the internet an advertiser-friendly environment. Additionally, state-level censorship is incredibly easy. If a state government takes offense to some piece of content, they can subpoena the company responsible for it very easily. Data in the centralized web is not secure by default. We're trusting companies to safeguard it against attackers and to use our data responsibly. Often they fail to do both, putting your privacy and finances at risk. You've probably heard the phrase, the internet never forgets, but anyone who's seen a 404 page will tell you otherwise. If a file is moved or a website goes down, the data is gone with it. Meanwhile, 90% of humanity's data was created in the last 2 years, and much of it is on the internet. The centralized web is a relic of a bygone era where consumer hardware wasn't very powerful. Most websites today are hosted on servers with less processing power and storage than a modern smartphone. If everyone has access to a supercomputer, why do we need companies to house our data? Instead of expensive data centers, the decentralized web utilizes unused resources on consumers' computers. Instead of a full-time security staff, it uses encryption to keep the bad guys out. That extra storage space on your PC becomes free real estate. And here's how it works. Since data in the decentralized web could be stored on anyone's computer, it has to be unreadable to everyone except those few who are allowed to see it. Before a file is uploaded, it's encrypted. Various encryption schemes can be used, allowing very secure control to who has access to the data. And the distributed web has to be resilient. The assumption is that any piece of data could disappear forever at any time. One way to protect against this loss is to simply replicate the data many times and spread it to many distributed nodes. However, replication incurs additional storage costs. Storing a file 10 times takes up 10 times the space as just storing it once. And this is called the expansion factor. Ultimately, the distributed web should meet or exceed the industry standard of 11 nines of durability. That's 99.99911 nines of percent of durability. Using simple replication, we see that even storing a file 16 times only gives us 10 nines, 11 nines if you round up, of durability. Luckily, this is why most decentralized data storage systems use erasure encoding. Erasure encoding divides a file into n pieces, and where k is the minimum number of pieces needed to reconstruct that file, and k is less than n. Using erasure encoding, we can achieve 13 nines of reliability in this example with only an expansion factor of 2, meaning that the file is only stored, it only takes up twice the amount of data that it would normally take, but we still get more nines of reliability. So a quick preface, this model that I'm describing is only one possible implementation of a distributed file storage system. Namely, this is the STORJ project's implementation, which we'll talk about later, but it can be done in many ways. So once the data is erasure encoded, the pieces are distributed to the storage nodes all over the world. Typically, there's 3 actors involved in this, the storage nodes themselves, the uplink, and the satellite. The uplink is just software that interfaces with the consumer application. It handles the requests for data downloads and encrypts, decrypts, and erasure encodes the uploaded data before being sent to the satellite for distribution. Satellites are not actually orbiting the planet, they're just servers running software that distributes the erasure encoded fragments to the storage nodes. Satellites also tell the uplink which nodes have the pieces of data needed to reconstruct the file that is being requested from the uplink. Satellites regularly audit the storage nodes to make sure that they are online and have the data that was assigned to them. Satellites also recognize whenever a file is missing fragments and will reconstruct that file, erasure encode it again, and redistribute the new fragments, effectively repairing data that was lost when nodes go offline. Satellites keep track of how much work each storage node performs and sends payment accordingly. So storage node operators take on considerable costs in hardware, electricity, and internet bandwidth. To incentivize people to rent their storage, they are paid in cryptocurrency. This allows a borderless instant payments system where they can send payments as small as 1 cent. This simply would not be cost effective using the traditional wire transfers, and it represents a great use case for cryptocurrencies. Distributed storage networks get to decide how to pay their node operators, and many set up their own reputation systems that reward data center-like qualities, such as storage capacity, uptime, and internet speed. They also punish fraud or negligence, leading to a decreased payout or sometimes disqualification. There are several projects working in the distributed storage space. I'm not going to argue which is best. You should do your own research, nor is this a complete list of all the projects that are out there. STORJ, PPIO, and SIA are very similar. They each use their own ERC20 Ethereum token to reward node operators, and they offer an Amazon S3 compatible interface for developers. They offer very competitive pricing, about $2 per terabyte per month, as opposed to Amazon's $25 per terabyte per month. They also deliver data faster than Amazon by downloading all the data fragments concurrently and dynamically storing popular fragments on nodes which are closer to the requester. IPFS is very popular, and it's a misconception that IPFS itself is a distributed storage network. It's not. IPFS is only a content addressable scheme. Think of IPFS as an alternative to the HTTP URL that we saw earlier. In IPFS, files are given a unique identifier, and that can be used to look up the file, regardless of the file's location in physical space. This separates the retrieval of data from the physical location of that data, making it a prime choice for looking up files in a distributed web, since a file could be in many places at once. In fact, many of these projects use or have support for IPFS and for retrieving files on their network. However, files don't have to be distributed to make use of IPFS. One last note, the developers of IPFS Protocol Labs are developing Filecoin. Filecoin hopes to be a decentralized market for storage. Think of STORJ, PPIO, and SIA as S3 alternatives and Filecoin as an underlying decentralized storage infrastructure. As always, do your own research. So in the early days of the internet, services like Twitter and YouTube felt more like protocols than companies. It was free to use, anyone could share anything, and everyone's voice was just as likely to be heard. Slowly, this became less and less the case as services deplatformed users, introduced algorithms that hack our attention spans, and polarize us with echo chambers and shouting matches, all in the name of engagement. The trend I see emerging from the distributed web is that it will not be free to use. However, you are not the product. The distributed web is an open platform that rewards anyone who contributes to it. In this way, your use of the web can be subsidized by the value that you add to it. This is an incredibly powerful virtuous cycle, and I think it ultimately results in a better internet that is secure by default, very difficult to censor, and ensures freedom before profit. Thank you.